Hello everyone. Today's video we are going to solve two very fundamental problems asked in CSIR NET June 2019. Read the first problem carefully. It says that the function f is given to u is a continuous and 1 function, and the function is from R to R. Okay. Depending upon this data, they are asking whether the function is onto or not. There exists, in the third option they are asking there exists x belongs to R such that fx is equal to 1. Fourth option they are asking about whether the function f is unbounded or not. The second option they are asking whether it is strictly increasing or decreasing. All of these things. Okay. We'll come one by one, and actually to solve this kind of problem you should be aware of some counter example. With the help of this kind of counter example, you can easily solve this kind of problem in the exam hall. Okay, so look at, for the third option, if we simply take our function fx is equal to e to the power x plus 1, look at this function is continuous as well as this one is 1 fine. But look at, is there any x belongs to R for which fx is equal to 1? Look at, there will be no such x for which this one holds. That means there does not exist any x belongs to R such that fx is equal to 1, which says that your third option is false. Fine. Now simply take fx is equal to e to the power x. If you take fx is equal to e to the power x, this function also satisfying the given conditions, but observe that if you set fx is equal to 0, then e to the power x is equal to 0 obviously has no solution, which implies that if you take point 0 from the codomain set, then it will have no pre-image in the domain set. Sure. Which implies that this counter example discards option 1. Fine. Which implies the function, this function fx satisfying the given condition, but this function is not onto function. Clear? Okay. Now what about the fourth option? For the fourth option you need to think a little bit, and if you take a function fx is equal to e to the power x plus 1 by e to the power x plus 1, if you take this kind of function, then observe what is happening here. E to the power x, obviously this is a finite quantity and it is greater than 0 and less than infinity. Fine. Now your function is fx is equal to 1 by e to the power x plus 1. So just simply construct it like this way. Fine. Now just take the reciprocal and you will have e to the power x 0. Fine. And this one is nothing but the given function or the function you have already constructed, which is satisfying all the given conditions. It is continuous 1. Moreover, look at your function, it is less than 1, greater than 0. That implies the function you have already constructed satisfying the given condition is a bounded function. But in the fourth option they are asking, or they are claiming, that the given function is unbounded. In the fourth option they are claiming that it is unbounded, but the function you have already constructed is a bounded function, which says that your fourth option is also false. Clear? Thus you have already eliminated 1, 3 and 4, these three options. So second option is the correct one. This kind of counter example should come in your mind in the exam hall, otherwise there will be little problem to solve this kind of problems in the exam hall in a very straightforward manner. Sometimes it will be very difficult also. Now come to the next problem, where a sequence of function gnx it is given to you like this way: nx by 1 plus n square x square, where x belongs to in this range. Fine. This sequence of function is given to you and they are asking whether it is uniformly convergent or not, what will be its pointwise convergent limit, and all that they are asking. Okay, to solve this kind of problem, look at, you should go in a very formal way, so that first of all you will find its pointwise convergence limit, then by the proper rule or proper approach you will check whether the function sequence of function is uniformly convergent or not. So look at, for x equal to 0, simply put x equal to 0 here and this will collapse and you will get 0. Now in the range this 0 less than x less than infinity, in this range you can simply take any point x equal to a, you can simply take and observe that your gn a, it becomes na by 1 plus n square a square. A is constant which lies between 0 and infinity. Fine. Now as n tends to infinity it goes to 0, as n tends to infinity. Clear? So in this range this is going to be 0, so you can simply denote it by gx and you will say that your sequence of function gnx converges pointwise to gx, where gx is equal to 0 and x belongs to obviously 0 infinity. Clear? Okay, so the given sequence of function, first of all it is a pointwise convergent sequence of function. Fine. Now we need to check, but wait, just wait, here the pointwise limit is 0, but in the third and fourth option they are claiming that the g and x converges to x and x by 1 plus x square respectively. So third and fourth option obvious false. Fine. Now to check whether g and x is uniformly convergent or not, simply we will find supremum of g and x minus gx, and if this quantity tends to 0 as n tends to infinity, then we will say that the given sequence of function is uniformly convergent. If it is not tends to 0, then we will say it is not uniformly convergent. Clear? That is the basic approach to check whether a sequence of function is uniformly convergent or not. Fine. So let's try to find this supremum of this one. First of all, gnx minus gx. Try to find this one. It will be, look at, nx by 1 plus n square x square minus 0, and it is nx by 1 plus n square x square. Look at, x lies between 0 to infinity in this range, so obviously x is positive and n is also positive quantity, so there is no point of giving modulus here. Okay, fine. Now look at, you have this quantity as mod of gnx minus gx. Now to find supremum of g and x minus gx, there is a certain trick you need to follow. 1 plus n square x square. Okay, just wait, take a pause here. Now look at, if we simply take 1 by nx and nx and use am greater or equal to gm, this formula, you will simply get this one greater or equal to 1 by nx into nx to the power half, and simplify this one, you will immediately get nx by 1 plus n square x square. This one is less or equal to half, which says that supremum of this quantity, supremum of this quantity or supremum of this quantity, obviously here is bracket or modulus, that will do no effect. So supremum of this quantity is going to be half. Clear from that point of view? Okay, now it is immediately clear that it is not equal to 0, or it is never tending to 0 as n tends to infinity. So by the earlier discussion, we can immediately claim that the given sequence of function is not uniformly convergent, which implies second option is also your false option, and the first one is the correct one. Okay, thank you.